So this is a pretty classic problem in calculus, but it has a bit of a trick to it. So there are plenty of series that we can see diverge very clearly, diverge very clearly, like 1 plus 1 plus 1 plus 1, so on, obviously diverges, right? You keep adding 1, you're never going to stop. And there are some that clearly converge, like 1 plus 1 half, plus 1 fourth, plus 1 eighth. That's going to go to 2, right? And you can show that using some pretty easy math. This one's weird, though, because it's not obvious that it diverges, but it actually does. And you might be told this is a theorem, but you might be curious why it's true, so here's why. Okay, so we have this in front of us, and we have infinitely many terms, and we're going to group them in quite an interesting way. Here's how we're going to do it. We'll take 1 in a group by itself and 1/2 in a group by itself. Now let's take these in a group, these 4 in a group, and these 8 in a group, and let's look at why. So, I'm going to show that every single one of these groups is at least 1/2, and these groups are generated by just doubling the size. So I had 2, and then I took the next 4, and then the next 8, and we could take the next 16, the next 32. And if we know that all these groups are greater than 1/2, we can add them to get keep getting 1/2. So let's show that. Okay, so 1 is obviously, we can see it's greater than 1/2, right? And 1/2 is greater than or equal to 1/2. So that's very easy. Okay, so let's start here. So first of all, you can obviously calculate this, right? It's fairly easy, but let's look at some logic. So we have a number that's greater than or equal to 1/4, and we're adding it to a number that's greater than or equal to 1/4, right? And that has to give us a number that's greater than or equal to 1/2. You can't add two numbers that are at least 1/4 and not get something that's at least 1/2, right? So that's pretty easy. This is greater than or equal to 1/2. Okay, let's look at these now. Well, really, we can use the same logic, right? These 4 numbers are all at least 1/8. So we've got greater than or equal to 1/8 plus greater than or equal to 1/8 plus greater than or equal to 1/8 plus greater than or equal to 1/8. And this has to be at least 1/2, right? Because we're adding 4 numbers that are at least 1/8. We're going to get at least 1/2. So this is pretty simple logic so far. Okay, so this is greater than or equal to 1/2. And this is the way that it works, right? We can also see the same logic that this is going to be at least 8 times 1/16, which is 1/2. Because all the terms are at least 1/16 and there's 8 of them, we're going to get at least 1/2. And so this is also greater than or equal to 1/2. And in fact, we can just keep drawing groups like this, right? There are infinitely many groups of numbers like this, because we could take the next 16 and then the next 32 and then the next 64 and so on and so on. And we can keep getting 1/2s. So what the series really condenses to ends up being 1/2 plus 1/2 plus 1/2 plus 1/2. And I'm writing 1/2 here, but really these are numbers that are at least 1/2. But at the least, it is 1/2 plus 1/2 plus 1/2, so on, if we go far enough. And obviously, this series is going to diverge, right? We keep adding 1/2, so we're going to get larger and larger and larger forever. And so by comparing this to this sequence, by drawing these groups of 1/2, we can see that the sum from n equals 0 to infinity of 1 over n diverges.